Good afternoon and welcome to the 21st annual exhibit of hydrogen and fuel cell technologies. Fuel cells are complicated. We used to think it's just putting electrical current into water and getting hydrogen and oxygen and running it back through a cell, and electrochemical energy comes back out the other end. It's far more complicated, and energy management is also a far more complicated issue. We'll be talking to a specialist who's Christopher Lange from Flexiva Automation and Robotics, and he's going to discuss power management of hybrid systems and potential approaches for Flexiva's next developments. Please welcome with me, Christopher Lange.
Yeah, thank you very much. First, I would like to introduce myself. I'm Christopher Lange, working for the sales and marketing department for Flexiva, and today's topic about power management of hybrid systems and potential approaches of Flexiva's next developments. Okay. Basically, just want to tell you at first something about our company. We are based in the east of Germany. Our headquarters are in Amtsberg, quite near to Chemnitz. We do have a subsidiary in Darmstadt. There we are producing, or we are doing the component assembly. And today I'm representing the department Alternative Energy Systems. The subsidiary for this department is in Chobau. Okay, never mind. The business units of Flexiva are switchgear construction engineering. You can see right on the left side. We are also dealing with component assembly, with robotics and programming. Yeah, and I already mentioned today I'm representing the business unit Alternative Energy Systems. Okay. So basically, what is our motivation regarding hybrid systems or renewable energies? You know, basically everybody knows the challenges we are all faced. That's overpopulation, that's sustainable development, energy resources, stuff like that. And we just want to take up the topic minimal pollution of environment, maximum production of green energy, and minimal carbon emission. And this is why we are working under the slogan, Think for the Future, Zero Emission. CMIS is our brand for all our services and our products. Firstly, I go into the topic prototyping, research and development with our CMIS energy kit, and after that I will tell you something about system integration with partners of us, for instance Studa and Super B, and after that I will come to the new approaches of Flexiva. Okay. Basically we are producing 5 DC-DC converter with different kind of voltage side. You can see it here. This is the voltage input, you know, and we are producing one DC-AC converter, which you can place in this 19-inch frame. You can put in up to 4 modules in it, so it works in a system up to 10 kilowatts. And depends on the use case you want to realize, you choose different modules. They are all working bidirectional and in a capacity of 2.5 kilowatts each module. So therefore we can ensure features like bidirectional power flow, high efficiency, and it's and big USP that it's appropriated for different kind of sources and storages. How it works basically, on the left side you can see a typical functionality of modules who are placed in 19-inch housing. You can see this is the 19-inch housing. They are placed in 4 modules. On this side, this side is connected with sources like fuel cell, PV, electrolysis, and yeah, stuff like that. And on this side, and 19-inch housing will create a 380 volt DC link. So it's you are able to easily combine different sources. Yeah, on the right side you see a functionality of parallel connection and series connection. The left side is the parallel connection. On the right side, it's the DC link side, the 380 volt. This is actually the series side where you can put everything in series. Yeah. So this is especially a solution for hybrid systems, for prototyping in hybrid systems, and also for laboratories and education. Okay. So this is a topic about system integration of top components from the market, and therefore we are working together with Studia. It's a company from Switzerland, and they are actually you are able to realize actually a lot of use cases with the products of Studia. They have a wide product range, but we are using Studia products for realizing especially hybrid systems. So we are specialized on hybrid self-consumption systems, autonomous systems, and hybrid self-consumption system works basically after priority. That means it firstly uses the energy directly from the sources which are connected. It charges the battery from the renewables, and if the grid blackouts, it takes the battery. So, but if it's not enough, the difference comes from the public grid. And autonomous systems works actually quite similar, but without public grid. I already mentioned products from Studia have a lot of futures. Studia is producing a lot of products. They have a wide product range, and here are the main features of products from Studia. And yeah, I told you we are creating optimized and customized hybrid systems together with Studia. Okay, a big advantage of Studia is the BLO. BLO stands actually for Battery Lifetime Optimizer, which ensures that the battery is not more than 50% deep discharged, and so the lifetime of a battery will be increased by 25%. And this is why we also decided to work with Super B, because they are really good designed to work with Super B. And besides the fact that Super B has an integrated BMS on the top of the battery, it has a lot of other features, like it's one-on-one replaced with HEM gear. So if you have already a battery, you can easily replace that. Okay, so what are our new approaches, or potential new approaches? Finally, we are trying to find a solution for this node. This is actually also we call it multi-converter power units. It will be sold as Siemens MCPU, and it's a flexible power interface for renewable sources up to 10 kilowatt. Well, I guess next year you will hear more about that, but currently it's just a project. It's a research and development project. These are the companies we are already worked for. We have realized a lot of products for these companies, and yeah, you are really welcome to visit our booth at booth 40. It's quite in the near of the technical forum, and if you have further questions, please feel welcome. Thank you very much.
Thank you. Thank you. I'm sure, yeah. Time for a few questions?
Of course, yeah.
Okay. Are there any questions from the audience? This is, of course, it's a very technical issue here, but whenever we talk about renewable energy, people generally know that there is a thermal side to it, thermal solar cells, or they produce electrical energy. What gets more complicated is what you do with that current, in what form it arrives, and how do you get it to the home consumer, and in what form? Is it 120 volts? Is it 220? Is it AC or DC? What interests me is losses of efficiency. And the reason that interests me is because there's a big question. If you have a source of renewable electrical energy, you could drop it into an electrolyzer, create hydrogen, which is easily storable, and use that when you need it on demand. Of course, the issue is still converting it back to electrical current or using it in the energy grid, storing it, using that natural gas grid as a storage facility. But simply, what interests me is if you run voltage from a wind turbine, what loss of efficiency do you have by the time it gets to a consumer? Would you have a ballpark figure for that?
Yeah, actually we already designed power electronics for small wind turbines. We don't work in the megawatt range. What I need to say we are always talking about the optimal use case. If the wind is blowing 36 kilometers per hour and stuff like that, it has an efficiency up to 96%, but it's still only on the paper, it's not confirmed in the practice, of course.
Still, that's very, very high. And what you mentioned, though, is also important. The small scale in the future is perhaps more interesting because one of the big energy wasters in Germany is the large grid. Piping electrical energy from the source of wind energy in the north to the south of Bavaria may not be the best solution. Certainly, using the energy close to the source would be more effective, wouldn't it?
Of course, but we are actually not focused on that kind of market because you already mentioned the grid in Germany is very good, but we do have in other countries where the grid isn't that good, like in Germany. So we are focused on smaller hybrid systems, but actually it is like that, yeah.
And certainly countries that don't have a grid locally would be the first clients if you need to set up an energy source in a small community that is not connected to a larger grid. Renewable energy and your technology would seem to be an easier solution than building a large source of energy like a power plant.
Should be, yeah.
We hope, we do. Yes, we do. Okay, are there any other questions from the audience? There's a lot to learn in this technology and a lot of research goes behind it. We always are impressed by Fraunhofer. If you have any more questions, visit the Fraunhofer... Flexiva. Flexiva, what am I saying?
Don't worry.
Flexiva. Where is the Flexiva booth? It's... do you have a booth on the fair here?
Yeah, it's a community booth with Fraunhofer. It's a booth together with Energy Saxony.
Okay.
And we are also there.
Oh, that's E51 over there.
It's B40.
B40, sorry.
Don't worry.
I'm messing it up. B40, okay. Join Christopher Lange there and continue the conversation on power management. Thank you very much.
Thank you very much.